The limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. That's what it's all about, right? Finding the derivative of a function. I left you with these 6 problems the last time we met, or the last time we saw each other, or the last time you had to watch me. Most all of you have submitted your answers right now already, which is cool. Some of you guys turn it in on Google Classroom, but you don't actually submit anything. So you should submit a picture, like you take a picture with your tablet or your phone or something, right? And you should submit the assignment. Don't just turn it in, because then I can't see it. It just looks like you just clicked turn it in, but then you don't have to do any of it. Isn't that great? That's not how it's supposed to work. So what was supposed to happen was we would have practiced this limit definition thing right here. Okay. We would have practiced this last semester. Get rid of all this other stuff. We would have done limit problems that just involved delta x. We would have had what I call the delta x problems. And it would not have been in terms of this slope and tangent line business. It just would have been, hey, look, here's some problems. And the question would have already been written for you. What makes this sort of exciting is I'm making you do 2 things at once here. You're having to take a function and take this formula and put them together. So that involves a much higher process. That's a lot more complicated to apply a formula with different functions. So ideally, we would have practiced a whole lot of delta x problems, the delta x limits. We never did any delta x limits. So now I'm trying to shortcut and speed it up. And today I'm going to speed it up even faster because we're going to quit using limits. Okay. But here's the 6 problems. I'm going to scroll through and say bye to me. Scroll through these answers, and hopefully this will all roll and work. Question 1, the answer is -5. Question 2, the answer is 0. So maybe, based off of the last video, you didn't do any work on question 1 and question 2. I did have one student in the class ask, do we have to show the work? Because I didn't. And I had another student who didn't show any work because they already took AP Calculus. And so once you learn how to do this, you don't want to go back to this limit formula. On number 1, obviously you see all that writing there. When you know the answer is -5, you just write -5 and you're finished, right? So if the function is -5x plus 3, the derivative is -5. F prime of x is -5. If the function is a horizontal line, like number 2, a constant function, right? Number 2 is a constant function, y equals 10. The slope of a horizontal line is 0, so the slope of the tangent line would be 0. No matter which x value you're sitting at, the derivative is 0. The function is a constant, and its derivative is also a constant, right? They're not the same constant because the function was 10, the derivative was 0. 3, 4, things get a little more exciting. Number 3, I worked out one almost identical, on the other video. This is x squared plus 2. The other video I just did x squared. So if you think about what we just said about problem 2, the constant on question 3, the plus 2 at the end, better get rid of that big marker and go to something else. The plus 2, if you think about it like this, x squared, its derivative is 2x because we saw that in the other video. And then the derivative of 2 was 0 because we saw that on problem 2 as well as in the other video. So once you get down to this last step where you plug in 0 for delta x, you just get 2x plus 0. Okay, notice how I did write the limit as delta x approaches 0, the limit as delta x approaches 0, the limit as delta x approaches 0, the limit as delta x approaches 0. You are supposed to write that limit every time, okay? When you're actually doing this formally, you are supposed to write that limit every time. Notice just past this equals, I wrote 2x plus 0. I've had students at this point ask me, in class before, remember we used to have school in class, they would say, what happened to the limit? Why does the limit go away? So eventually the goal is to plug the number in that you're taking the limit at, right? So I'm taking the limit as delta x approaches 0. I want to plug 0 in for delta x. So then I don't have the word limit anymore, or the LIM, right? It's just 2x plus 0, which is 2x. Okay, so question 3, same answer as what was on that other video. Question 4, notice I put a negative 3x squared. So if the derivative of x squared was 2x, maybe you just had the thought, well, the derivative of negative x squared is negative 2x, and you'd be right. What's the derivative of 3x? Well, going back to problem 1 up here, as well as 2 of the examples on the previous video, negative 5x plus 3 is a linear function, right? And the derivative was negative 5. So down here, 3x is a linear term, right, on 4. The function is not linear. This is a quadratic function because it's x squared. So that's like, the bigger power and all takes over. But 3x is a linear term. So what is the derivative of 3x? Just ignoring the x squared for a moment. It would make sense that if there was no negative x squared, the answer would just be 3, right? Just like on problem 1, the answer was negative 5. So you could think of each term individually and maybe deduce what the answer is going to be and take yourself from having to do all this mess. Now I've got all this mess here, and I will post these notes as a PDF, so you can kind of go through the PDF if you want, or you can rewind the video and watch it if you want to go back and look at certain numbers, obviously. But I'm trying to show lots of steps. I'm trying to use different colors so you can see how the function is one color, like on 4, the function's in the black. The formula is purple, but I'm using the purple, and eventually it all becomes purple, to kind of show the change from the function to the derivative. So again, what should happen when you do the algebra correctly is every term in the numerator of your limit that does not have a delta x should cancel out. So you see that I started underlining here in problem 3 and 4 with red. Negative x squared, positive x squared cancels out. Positive 3x, negative 3x cancels out. And then there are 3 terms left over. Okay, these 3 black terms on top all have a common factor, right? They have a common factor of delta x. And that's really the only common factor you want to take out. If they had a different common factor, I would just leave it. I would just factor out delta x like I did down here. So I rewrote the numerator with the 3 terms in purple, and I shed out, right? I'm hearing everybody say shh, the delta x. And then the delta x's cancel out, and what's left over is negative 2x minus delta x plus 3. Then I apply the limit as delta x approaches 0. So this second to last step, I plugged 0 in for delta x. Now, ideally, maybe you don't have to show this part right here because you're like, bro, negative 2x minus 0 plus 3 is just negative 2x plus 3. Okay, so I'm kind of showing every little step. Maybe that will help. Normally, I wouldn't do that. Normally, I'm not going to do any of this because we're going to find in just a couple of minutes a better way to take a derivative. Okay, and so what's happening here on 5 and 6? 5, it's a 3x squared, and we've already seen 3 times now, the derivative of x squared is 2x. So if the derivative of x squared is 2x, and you have 3 of them, because it's 3x squared, right? You could almost think of the problem this way, like this is x squared plus x squared plus x squared. And if the derivative of x squared is 2x, then the derivative of 3 of them would be 2x plus 2x plus 2x. And what is 2x plus 2x plus 2x? That's 6x, which is the answer. Right? If the derivative of x squared is 2x, 2 times x squared makes 6x. Sorry, 3 times 2x. I think I said that completely wrong. So here's the algebra on problem 5. Again, you have to FOIL the binomial x plus delta x quantity squared. Normally, I usually work that out in class, but if I take time to do this, a whole another 5-minute step. So you FOIL. Maybe you should just practice this FOIL by yourself. Just do x plus delta x if you don't get what I've done. Try that problem right there, just on your own. FOIL, right? First, outside, inside, last. And you will get what I wrote here in green, but then you have to distribute the 3 out front because it's 3 of them. So instead of getting x squared, you have 3x squared. Instead of getting 2x delta x like we got on problem number 3, it's 3 times 2x delta x, which is 6x delta x. And then you get a 3 delta x quantity squared. Minus 3x squared, so you notice that 3x squareds go away because they don't have a delta x term. That will always happen. If you have a term without a delta x and it doesn't cancel out on its own, you made a mistake. Okay? the terms without the delta x will always cancel out on their own, always. Because what has to be left over are 2 or 3 or however many terms that all have a delta x in them as a common factor, so we can So I'm hear everybody say a delta x out, right? So when you the delta x, it cancels delta x out of the bottom, and that's the goal in every single problem. Delta x must be removed from the denominator so that I can plug 0 into all the delta x's. So on 5, you get 6x plus 0, which is 6. Question 6, maybe you were just like, yeah, nose goes on that. I did look at a couple of the homeworks that were submitted. I've looked to see who submitted them, and I know who submitted their homework, but I didn't open every single one of them up and grade them, because like, who's got time for that? Nobody got time for that. I noticed a few people did not submit anything; they just turned it in. So you got to submit a picture and turn it in, okay? But then I'll put the answers up so you can check yourself. Okay, so don't just submit like a bunch of tiny writings like Cork's never going to read this because he's bull. Ha, 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 ha. You know, like if you do that and I don't catch you, then congratulations, you're like really awesome. And like someday you'll be like 40 years old and you can like tell your kids like, yeah, I was in AP Calculus and like I never like did any homework. I just wrote a bunch of crap like on a piece of paper and I would submit it on Google Classroom. So I'm like so cool. And like the teacher never caught me because he's like so lame because he sucks. And then that's really cool. And your children will think you're some kind of freaking hero. You'll be like, wow, you're so awesome, Dad. You like got away with it. And by that point, like I'll probably be dead maybe by then. So congratulations, you won. I'm dead. If you don't want to do the homework, then like maybe get out of the class or something. I don't know. Or just don't do it. I guess we'll see. I don't know. I'm torn. Like you do this because you care. That's the point, right? Anyway, notice the answer for 6 is 3x squared. If you need to go back and read all that, oh, Marty, look what you did. Sorry, let me fix this. That's a cube right there. I wrote a square because I've been in square mode. The function is x cubed. I have to do x plus delta x cubed minus x cubed. And what is x plus delta x cubed? Well, if you look at the very bottom of your screen, that would mean x plus delta x times x plus delta x times another x plus delta x. And that is no longer a foil, right? That is like a monster foil, super foil, mega foil, right? It's a binomial cubed. So you got a lot of parts. And when you do that, you will end up combining a bunch of like terms, and you should get x cubed plus 3x squared delta x plus 3x delta x quantity squared plus a delta x cubed. And then the minus x cubed at the end is your function, minus f of x. And the x cubes then cancel out. So I highlighted those in yellow here. And then I underlined x cubed, x cubed, x cubed. There's 3 terms left over, and they all have an x cubed. So what can we do with that x cubed? What can we do with that delta x? We can like the delta x out front, right? Let me hear it. Delta x out front. So the delta x gets factored out. It's the greatest common factor. And what's left over after the delta x cancels is 3x squared plus 3x delta x plus delta x squared. And you can plug in 0 for the delta x's, right? Plug in 0 for the delta x's, and you get 3x squared plus 3x times 0, which is 0, plus 0 squared, which is 0, and 3x squared plus 0 is 3x squared. Okay, it's all right here. So at this point, how long has the video been? I'm not sure. Do I have a way of figuring that out? I don't think I do. It used to. There's like a bunch of other videos that I made last year, and as well as right now. Yeah, it used to show me like you'd see the timer going, but I don't think I can see that anymore. So I have no idea how long this video is. But after you watch the video once, you'll know that you can fast forward to this moment. Mark the moment of the time of the video. Maybe it's 7 minutes. I've already taken too long. I really thought the first part was going to take me like 3 minutes, but I always talk too much. Here's all the answers. Maybe I should have just done it this way. Here's all the answers. If you want to see how the answers are worked out, then you can scroll up the notes and look at them. So I will post these notes as a PDF, and then I will also post a link to this video. Okay. Ideally, we would still be doing this in pre-cal, talking about derivatives. And so I put them next to each other so we can see them paired up. Maybe we can start to recognize a pattern. Notice the -5 had an x with it, and then the -5 is the answer for the derivative. The x kind of magically disappeared. Notice the 3 that does not have an x with it just goes away. 10 does not have an x with it, and it goes away. It's 0, right? X squared becomes 2x. Negative x squared becomes negative 2x. 3x squared becomes 6x. X to the third becomes 3x squared. So I kind of joked about this in the last video that it's like, can I just like pull that power down, put it out front? Like, you look at number 6, the 3 went out front, right? See how there's a 3 in my derivative? 3. And the power is now 2, right? It used to be a cube, and now it's a square. So the power went down 1. If you look at problem 5, look, the power was a 2 in the function, but in the derivative, the power is not a 2 anymore. It's a 1. The power went down a number. And 3 times 2 magically happens to equal 6. It's almost like if I were to take the coefficient of the term, like on number 4, the coefficient is -1, and multiply the coefficient by the power. What is 2 times -1? That's -2. And then do 2 minus 1. Subtract 1 from the power. You would get x to the first. Normally this happens in class, and I have a big list of these on the chalkboard like you see right now, and it starts to kind of click, and everybody's like pointing it out to each other because some kids are like, what the hell's going on? Because I've been playing on my phone the whole time, or I've been playing on my tablet. You know, like there's a new basketball game or something on the tablet. I guess it's football season now, so we have Madden 21. Everybody's playing that. But this is the power rule for derivatives. And once you recognize this power rule, why would you ever want to do the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x? It's why Ethan Rudd in his homework didn't write out all the limit stuff, because he already took calculus. And it's like, bro, I'm never going to do this limit stuff because I know the power rule. So usually in pre-calculus, we spend a lot of time doing the delta x limits. We kind of shortcutted that. Now I'm shortcutting even faster because the last video talked about finding derivatives using delta x limit definition, right? Now we're not going to use limit definition anymore. We just want to try to like find the derivative. So maybe I can do this quicker and get it over with. So let's use this pattern. And you see I made a few examples up. Here's 7 and 8. Okay, after 6 comes 7. My derivative, y prime. And that's one of the things I'm going to talk about today is different notations for derivative. Okay, if it's f of x, the derivative is f prime of x. If the function is written y equals, then the derivative is y prime. Y and y prime are definitely the best notation. It's definitely the best way to write it because it's the least amount of writing. But I'm going to show you some other things that we got to talk about. But oh well, that's different. Number 7. What is the derivative of x to the 4th? Well, what you do is you multiply the 4 times its coefficient, which is a 1. And what's 4 times 1? 4 times 1 is 4. X to the, and what do you do to the power? What do you do to the 4? Is you drop it low, drop it low, right? The power goes down 1. 4 minus 1. You subtract 1 from the old power and make it a 3 in your derivative. So the derivative of x to the 4th is 4x to the 3rd. And that's way better than having to do x plus delta x times x plus delta x times x plus delta x times x plus delta x, right? And having to do what you see at the very top of the screen, right? This binomial multiplied by itself 4 times. That's a lot of algebra to have to write all that out. And then what will happen is all those delta x terms will go to 0, and then you're just left with 4x cubed. Okay, cool. So now 5x squared, we've had x squared a couple of times. X squared shows up a lot, you know? It's like everybody's buddy. But what's different about it, now there's a 5 in front. So what do? Is you do 2 times 5. What's 2 times 5? 10. And then you do 2 minus 1. What's 2 minus 1? X to the 1st. And do we have to write 10x to the 1st? We don't have to write the 1, right? But you can. It's not wrong, but you don't have to. And then look at the 2. 2 does not have an x term. If I put an x after 2, it means 2x to the 1st. So if I don't want it to be there, I make it x to the 0. Remember, that's the property of exponents. Is that if anything, x is a 0 power, it's actually 1, so 2 times 1 is just 2. So when we want to write the constant 2, we just write a 2. If you want to put a power of x, you make it x to the 0. And so what happens now is you do 0 times 2. And what is 0 times 2? 0 times 2 is 0. And then it would be x to the, what's 0 minus 1? Because you subtract 1 from the power, right? -1. But I don't need an x to the -1 when I times it by 0, because 0 times x to the -1? Just 0. I really just have plus 0. And do I need to write plus 0 at the end? No, I don't. Like going back to problem number 1, remember the answer on problem 1 was not -5 plus 0, it's just -5. So, power rule, boom, we're off and running. We're taking derivatives now, right? So q of x, if you want, pause the video real quick and work out q of x. The first thing is q has a derivative of q prime. So the derivative is q prime of x. And now I power rule it, right? So if you need to, pause the video, work it out. Now unpause it. There's your answer. 7 times 13 is 91, which is kind of cool because, 713 is pretty cool. Right, Z-Bird? Right, Bird? 713? I hope you had a good birthday, Zach. I started high school in 1991, so 7 times 13 is 91. That's pretty cool. I'm sorry. I started my senior year in 91. I was class in 92, so 91, 92. Big deal. September 24th, 1991, Nirvana's Nevermind came out. Changed the face of everything. Okay, it's my opinion that because of Nevermind, we now have the internet. Okay, so anyway, that's a whole nother conversation for another day. But big Nirvana fan here. 3 times 9 is 27. 13 minus 1 is 12. 9 minus 1 is 8. So you multiply the power times the coefficient, and then you subtract 1 from the power. Okay. So what have I got next? I have a long problem that I made up. And this time, I want you to work it out, find the derivative. Okay, I probably should have said make the top. Let's just say find y. Find the derivative. I didn't really give any directions as to what we're doing. I'm just writing things, and that's not really good. Derivative. Find the derivative. Notice on 7, the derivative is y prime. Notice on 8, the derivative is q prime of x. On 9, look, it's a y again. So pause the video now, take a minute, find the derivative. And then unpause. Okay, pause. Now unpause. So now have you unpaused it yet? Gosh, I don't know. Do they know to unpause it? What if they paused it because I said pause it? Now it's just sitting on pause forever. And they're like, crap, I don't know when to unpause it. Hopefully they'll figure this out. Here's the answer. Maybe you've managed to find unpause by now. Y prime is there. And it's maybe I screwed it up. I haven't multiplied 9 times 8 in a while. Is that 72? 9 times 8? 72. X to the 7th. 42 x to the 5th. 54 times 3 would be like having 150 plus 12. So 162. And then 2x. So there's the derivative. Now here's something else that I got to do that's kind of annoying. You notice in front of my y prime, I wrote an equal sign. You might be thinking, ooh, why is there an equal sign? Turns out there's another way to write the notation for a derivative, a very popular common notation that I have to talk about that we haven't talked about yet. And that would be dy dx. Okay, first of all, let's say y prime is better. I like y prime. I'm usually going to write y prime like 99% of the time. But dy dx is sort of a derivation on delta y, delta x, right? For slope. It literally is a derivation. We're talking derivatives. Delta y over delta x is slope. Dy dx or dy over dx is still slope. This time we're using the English letter D instead of the Greek letter D. So the triangle for delta is the Greek letter D. Like it goes A, B, C triangle. In the English alphabet, we have dy dx. So dy dx literally stands for the derivative of y. Derivative, come on, of y with respect to x. Man, it doesn't write very well when you're near the bottom. or I just don't write very well, period. Derivative of y with respect to x. Derivative of y with respect to x. And I have to show you that because you'll see this notation creep up a lot. Okay. Problem 10. I thought I wrote it again, but I guess it's coming later. Find the derivative of y. That means the derivative of the function. And the with respect to x tells me that my variable is x. Okay. Maybe I was going to wait to introduce dy dx when I wrote the power rule in a minute. And because when you write formulas, a lot of times you'll use different letters. So you need to know which letter is your variable. But with respect to x is telling you that x is your variable. Okay. Sometimes you write functions like ax to the k power. So you have a and you have x and you have k. And a and k would be like constants, right? They're just holding the space of a number that you don't know. But x is your variable, or t is your variable, or q is a variable. So like if you had dy dq, then you'd know that, I'm taking the derivative with respect to x. So it means the function is y equals something about q instead of y equals something about x. Example 10. Power rule seems pretty simple, right? So how can it get worse? Well, we can have functions that are slightly more like flavorful. So like on 10, you have 1 over x squared, and you have plus the square root of x. And so you might think, well, square root of x doesn't even have a power, and on 1 over x squared, the power is in the denominator. Can I still do the derivatives like that? Like is y prime going to be 1 over 2x? Is that how I do it? No, that is not how you do it. So the way this thing works is, remember, it's like back to number 9, that x to the 8th power is in the numerator, right? The variable x on everything that we've done so far is in the numerator. So if you ever have a variable in the denominator, there's either a whole nother rule that applies that we haven't learned yet, because the only one we've learned so far is the power rule, right? Or you have to rewrite the problem. Okay, so there are times when algebra happens first. I remember actually 1,000 years ago, my teacher telling me, and so now I'm telling you, most calculus problems are 95% algebra, and then you have 5% of calculus. And what I like to add to that is usually the calculus step is like the easiest part. The algebra that takes you to the final answer is what really is the most cumbersome, because you do the derivative and then you have to get a common denominator and you have to add fractions together and you have to do all this algebra. Okay. So the derivative is like, oh, cool, I got derivative down. But it's all that algebra that you've learned up till now gets used at any one moment, which is pretty cool. It's like calculus is like, I like to say it's like fighting ninjas. This sucks because like in class, I'll be fighting ninjas. And since I already turned I turned the video camera off. But I can't, dang it. Man, this is a bummer, man. We can't do dance moves. Like usually for derivatives, I do this. Whoop, whoop, drop it, Anyway, when you're going to fight a ninja, the ninja doesn't say, hey, be prepared for a Judy chop, and to deflect a Judy chop. Or maybe it's a karate chop. The ninja don't be like, hey, here comes a karate chop. Ninja's just going to start whooping you. So you got to be ready for all these like algebra moves. The algebra is just anything you've ever learned in math up until this point is now fair game in calculus. Like maybe you need a logarithm, maybe you have to raise something to a power. Like all the algebra is now like a part of the rules, in the game of calculus. Ninja star, So what's 1 over x squared? 1 over x squared can be written as x to some power. Right. Plus, the square root of x can also be written as x to some power because you learned properties of exponents. So, boop, boop. How do you move the x squared out of the denominator? Dang, this is not good. I guess I'm going to have to leave my video camera on when I make these videos. I like to have it on at the beginning and then turn it off because I end up looking at myself the whole time. It's so pretty. Anyway, just shut up, Marty. This is a -2 power. This is a 1/2 power. Ideally, I would be asking you in class right now, but we're not having Google Meets today because your buddies in JCPS can't do school properly. I was going to be teaching all this in a Google Meets today, and I'd be in the middle of a Google Meets right now. It's 12:42. I don't know which class that is. I think that's 6th period. What's up, 6th period? BC Calculus? Whoop, whoop. Now the problem is set up to where I can take a derivative, y prime, right? Or I can write dy dx. the derivative of y with respect to x. And what's the derivative of x to the negative second? Okay, the way that works, remember, is you take the negative 2 times it by the coefficient. Coefficient is 1. So what's negative 2 times 1? Negative 2. X to the, now is where it gets tricky. Now is where you got to drop it. Now you got to drop it low. You got to drop it low. You drop the power down 1. Okay, so from negative 2, if you go down 1, you're now where? You're at negative 3. Plus, what's the derivative of x to the half? That would be 1/2 x to the, you got to drop it down 1. Maybe I went too fast. Maybe you're going quirk. Where's the 1/2 come from? Again, a square root means 1/2 power. And then I do the 1/2 power times the coefficient out front, which just happens to be a 1 again. So it's 1/2 x to the, drop it down 1. What's a half minus 1? I have to subtract 1 from a half. So what's 50 cents minus $1? A negative 50 cents, right? Negative a half. And there's my derivative, assuming that's a good enough answer. Okay. Sometimes on multiple choice questions, they'll now rewrite the answer in any number of algebraic ways. This is why I was hating on the algebra a minute ago. Because this right here is a suitable answer. You found the derivative, technically you're finished. Okay. And the way this would work on the AP exam is if it's a free response question, you can stop. On a free response question, you don't have to do any simplification unless they ask it for in a certain form, or they tell you. But if it's multiple choice, right? If it's multiple choice, the derivative might actually be negative 2 over x cubed, like that, right? Plus 1 over 2 square root of x, because you can move the negative powers to the denominator, make them positive. You can rewrite a half power as square root, right? The 1/2 already has a 2 in the denominator. So the x to the negative 1/2 goes down and hangs out with that 2. Whereas the x to the third in the first term, there's no other term in the denominator. So that might be the answer if it's multiple choice. Maybe what they do now is get a common denominator. Would that not be terrible? It would be terrible. So I'm not even going to do that. But so there's power rule. We're doing power rule. At this point, you might think, why would I ever use that silly limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x? Why would you ever do that formula? And I get it. One time many years ago, I've only ever seen this one time, there was a free response question on the AP exam where part A says, what is the derivative of this function? And you're like, oh, it's cake. And you just take the derivative. And then part B said, verify the derivative using the limit definition. And then all of a sudden it's like, oh, dude, we haven't done that since like August or since like junior year, And so like, that's why I have to keep mentioning the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. That limit definition of the derivative, it's written down here in a minute. You're going to see it again. It's important. It's what's holding everything up. All the other rules that we have in calculus, we have to prove them using the limit definition. Then we know that we can use those rules. So that's kind of like, it's like your basement, you build the basement first. That's the foundation of your house. So we have limits that kind of hold up calculus, but then we hang out up in our bedroom. We don't usually go to the basement much because that's where like, all the junk is, the Christmas tree and all that stuff's in the way. So, although maybe your basement's cool. I bet some of you guys have like basements with like pool tables and video games and, all that like beer fridge and all that cool stuff. Mine's not like that. It's just a mess. Anyway, problem 11. Here's a big mistake that I will see very often. Okay. Very often I see this mistake. So I'm trying to get you guys to like not make these mistakes right now. Let's switch to a new color. Let's go to orange. You want to find the derivative, find y prime, right? Okay. And so you might go, oh, I have to rewrite this square root right here. I have to rewrite this variable in the denominator. But I know how to take the derivative of 4x cubed. The derivative of 4x cubed is negative, what's 4 times 3? 12. X, what's 3 minus 1? 3 minus 1, 2. Right? And like, oh, I got that part done. And then people will be like, oh, well, this is now what 3x to the 1/3 power, because remember with exponents, when you have radicals, the exponents are fractions. The index is the denominator of the fraction, and the power of x under the radical is the numerator of the fraction. So it's 3x to the 1/3. And then I have, x to the -1. And then there's my derivative. Ta-da! Right? And that's bad. That's really bad. Because what you just did was you didn't find the derivative. You rewrote part of the function, and then you also took the derivative of part of the function. You like mixed and matched it. Okay, this right here is still y. So I'm gonna go back to purple. Y equals 3x to the 1/3 power minus 4x to the 3rd power plus x to the -1 power. I'm just going to get rid of the orange completely. 3x to the 1/3 power. See, I've rewritten y. This is y equals. This is y equals. If you have to rewrite something, I suggest rewriting the whole thing as one extra line, okay? If you try to start taking derivatives of parts and then rewriting parts, you will mix them up and mess it up. Now, maybe you won't. You're the one that does everything perfect. You never make mistakes, and that's awesome. So you're like, Quirk, I don't really have to listen to you because I know how to do this, okay? You're the one that grew up to become a teacher. Maybe you need those steps. I'm just giving you observations that I've made in 22 years of being a teacher. I haven't taught calculus for 22 years, but these are just some mistakes that happen. Some of the mistakes. So now I've taken the function and rewritten it. Now I can take the derivative, okay? Another word for derivative I haven't used yet is the verb differentiate. Okay, I need to say that eventually. Sometimes the directions just say differentiate. So the big word actually is differentiation. Differentiation is actually the title of our chapter that we're in. Chapter 2. Chapter 1 was limits. Chapter 2 is differentiation. And differentiation is the process of taking a derivative. Okay, so when you say find the derivative, you're talking about the noun, the derivative. When you use the word differentiate, it's the verb because it's telling you what to do to the function, right? So English is important and all. So now I'm going to differentiate 3x to the 1/3. And what is 1/3 times 3? A third of 3 is 1. X to the, what is a third minus 1? What is 1/3 minus 1 or minus 3/3? 1/3 minus 3/3 is -2/3 minus 12x to the second. So there's our power rule with good, pretty numbers. No fractions or negative numbers, right? But that has to come on the y prime line. You can't write that back up with y. That's wrong. And now what's the derivative of x to the -1? It's negative x to the, drop it down 1. You go down from -1 to -2, right? You borrow $1 from your friend on Tuesday, and then on Wednesday, you're like, bro, I can't pay you back. I need to borrow another $1, right? So now you're 2 in the hole, right? Down 1, down 2, okay? So there's the answer. Can I leave it like that? Sure. Can it be written other ways? Sure. There's definitely other ways to do it because of the negative exponents and the fraction exponents. I'm just going to stop there for now. I'm not going to spend any more time on algebra because I actually thought this video was going to be short. I really did. I was like, man, they're going to be so happy with you with a 10-minute video, and it's probably been 48 minutes already. Power rule, how many more examples I got? Look, 16. Like we're going to 16, then we're done. But what I haven't written yet is the actual power rule that you'll see written in your book, which you don't have. They get you all a copy of the book somehow. And this is written a whole nother way. Look, there's a ddx. What in the heck? Of x to the n power. So far in the first 10 examples, 1 through 10, I wrote them as functions. I wrote y equals with an equation, right? And then y prime equals. Derivatives don't have to be written that way. They don't have to be presented as functions. You can have an expression like you see in problem 11. And that's the way the rules are written. The formulas, they're not going to be written, y equals this, then y prime equals that. It's just written the derivative of equals. So what is the derivative of anything that I can have written as a variable x to the power n? And this was kind of alluding to this earlier in that notice x and n are both letters. So you might think, well, which one is the variable? Is n the variable? It could be, right? Because you can have 2 to the n power, right? That's not what we're talking about here, right? We're talking about x to the 2 power, right? We're talking about the power being a number. And so why don't you tell us, bro, that the power is a number? Well, I am telling you that because the denominator says dx. The x is telling me that x is my variable. So what is the derivative of x to the n power with respect to x? This is the whole derivative of y with respect to x thing. The dx on the denominator tells me my variable is x. So this is the power rule. This is the formula for the power rule. And I might as well back so it's all written one pretty line. N times x to the, and what do you do to the power when you do the power rule is you drop it down one, right? N minus 1. So Jeff's back. Jeff, you good? Oh, he wasn't talking to me. Jeff's here, so y'all know. Talking to myself down in my den. Jeff's gonna think I'm crazy. N times x to the n minus 1 power. That's the formula for the power rule. Okay, that is the derivative of that thing with respect to x. That's the formula for it. So now you just follow this pattern over here. And honestly, looking at the formula, you might think, well, that looks more confusing. I just like to do it with the numbers. And that's cool. It definitely helps to have the numbers. The numbers are better. So what is the derivative of 3x with respect to x? D dx is the derivative of 3x with respect to x. It's just 3, right? 3. What's the derivative of 7x squared? 14x. Okay, so question 11, that's one way to ask derivative. And that's what I've done with these last few is I've asked to find derivatives in different ways. So 11, that's new. We haven't seen it that way before. ddx of 3x plus 7x squared. 12, this is definitely more of like straightforward. Find the derivative of f of x equals 2 minus 10x cubed. So what are they asking you to find there? The derivative. How do you know they want you to find the derivative? Because it says find the derivative. You know what I'm saying? So that's the best way to do it. This is more notational, right? Come on, auto saving. That's a more notational thing. It's less writing for me. So I also like the y prime thing. So what is the derivative of f of x? It's f prime. What's the derivative of 2? 0. What's the derivative of negative 10x cubed, negative 30x squared? 3 times 10. Drop the power down 1. Drop it, drop it. Okay, cool. Here's another way to do it. If y is equal to 100, x to the 100th power minus 100, find dy dx. Oh man, what does find dy dx mean? Again, that means find the derivative of. It's just less writing. It means find the derivative of y, right? Y is here, right? So this just means, dy is 100 x to the 100 minus 100 dx. Like it's written back in problem 11. You know what I'm saying? So it's just, this is all new notation. It's calculus, Step 1 is just kind of learning how it's written. But all these things mean the same. Find dy dx, that means y prime. If you prefer to write y prime, you can write y prime, right? Y prime. What's 100 times 100? That would be 1, 0, 0, 0, 0. 10,000, x to the, drop it low, drop it low, 99. And then what's the derivative of 100? The constant, 100, is 0. 1,000 x to the 99. Derivative. Cool. Oh, man. What's the limit as delta x approaches 0 of 7 times x plus delta x cubed plus 5 times x plus delta x minus 4 minus the quantity 7x cubed plus 5x minus 4 all over delta x? Oh, you're crazy. I'm not doing this, Quirk. I'm not going to do this whole like cube binomial crap and distribute the 5 thing and then distribute the negative sign and then combine all the like terms and then I the delta x out and then I cancel the delta x. I'm not doing all that. And that's the good news is you don't really have to. This is what we're hoping is that you're going to like get smarter. And I've said this every year until now. I can't say this anymore. Every year on the AP exam, there has been a multiple choice like question 14. Okay. The first 45 questions on the AP exam are multiple choice questions. Okay. 45 multiple choice questions. And this could be number 14. This would be a no calculator question. Some of the questions you get a calculator, some of the questions you don't. And when you see this problem, it's multiple choice, right? This problem should take less than 10 seconds. it even takes probably longer to bubble the answer in than it does to know what the answer is. And because you're not going to cube this whole binomial thing, you're not going to work all this out like you would have supposed to have done in your junior year, you know, when I make you do all the terrible math. What you're supposed to do here is just go, oh, this is the formula for the derivative. This is the limit definition of the derivative. And it's the derivative of what? What is your function? Anybody know where the function is hiding here? The function is after the minus. It's in the parentheses. That is the function. So when you look at this problem, I don't want you to do all that terrible math that you had to do when you were a junior. That was a part of like the character building. You know, it's a part of going through the hoops. Everybody else had to do all this damn algebra, so you had to do it. Now you know a better way. This is literally a 5-second question on the AP exam. Now, I say it's on the test every year. It wasn't last year because they didn't put multiple choice on the test last year. Will there be multiple choice on the test this year? I have no idea. Maybe AP is going to like change all of their tests from now on, make everything free response. They have not said that yet, right? So we're in a weird time because I would normally do bunches and bunches of multiple choice questions. And I actually have a Barron's guide that I give each one of you. I'm thinking I'm not going to give you the Barron's guide, obviously, because we may not ever go to school. But I'll just maybe post some multiple choice questions from time to time for practice. But if they come out and say, oh, we're not going to do multiple choice, well, then I would highly think that this question, number 14, would not necessarily be on the AP exam unless it's multiple choice. They don't want you to work this out by hand. And if they ask you to, then that sucks. I'm not saying they couldn't. They could ask you to, but here's my function. F of x is 7x cubed plus 5x minus 4. What's the derivative of that? So 21x squared plus 5. What's going to kind of suck is when I do math problems in class, you know, I make mistakes and everybody like yells like, Cork, you're a dummy, you know, 7 times 3 is not 18. And if I make mistakes on this video, I may never know it. So that's a problem. You guys might have to speak up, you know, in our live sessions, be like, yo, Cork, you screwed up on the video. So that other people don't have it wrong. But like that's all is expected for this problem, okay, is that right there. When you see this crazy big limit definition, you just go, oh, that's the definition for the derivative. That is the formula for the derivative. So then take the derivative using power rule or another rule. And that's the thing we haven't gotten to yet. Is there are a lot of rules. There's a rule for cosine, right? There's a rule for log x, right? So we can't use power rule if the function is log. We don't know how to do that yet, right? What if it's ln x? Power rule doesn't work. So power rule only works when we have x to a power, okay? Like here at this formula, the top of the page. See, it's x to a power. It's not the natural log of x to a power, right? It's just x to a power. So we're starting the basics. 15, 16. Man, I'm sorry. I wanted this video to be fast. I'm never going to be able to make quick videos. How am I going to make the videos faster? Find the slope of the line tangent to y equals x squared at x equals 3. So this kind of gets back to where we started with our first video and finding a slope of a tangent line. Again, when you read, find the slope of the tangent line. I guess I shouldn't put derivative. Find the derivative. It's just so much faster to write the word derivative instead of slope of the tangent line. Find the derivative to y equals x squared. What's that? Derivative of x squared, 2x. At. So now we actually get to do something because we are talking explicitly about slope here. And the slope of a line is a number. The slope of the line is a value. The derivative is usually a function. So you see this 2x, that's a function. The derivative is a linear function. The derivative of a quadratic is a linear. Whoa, every time. The derivative of every quadratic is a linear. The derivative of every linear is a constant. The derivative of every constant is 0. So there's kind of a pattern to all that. But what is the derivative at 3? What is y prime at 3? That would mean 2 times 3. What is 2 times 3? 2 times 3 is 6. 6 is the slope of y equals x squared at x equals 3. And it depends on which x I'm using, right? Like if x was 10, the slope would be 20. So the slope of a parabola is not always the same thing, right? Around a parabola have a different slope at every x. What if I said, what's the slope at 3.5? Well, then that's 7, right? It's different. Every number, the slope is different. So I was looking at the problems in the book in this section, and I noticed there was a couple of like square root ones and fraction ones that had variables in the denominator, and I thought maybe I should point out some sort of differences. So that's why I made up this last problem. At this point, I kind of just want to quit, but might as well finish it out, right? Mostly here, the difference between part A and part B. Notice on part A, there's an x cubed in the denominator that can come up as a negative third power. Right? The coefficient of the variable is 2/3. On part B, you want to cube the denominator first. What is the coefficient of the variable, on part B? Well, you want to multiply out 3x cubed. What is 3 times 3 times 3, or 3 cubed? And what is x times x times x? X cubed. So the denominator is 27x cubed. So the function has a coefficient of 2/27, x to the negative third. Okay. And then we find our derivative. The y prime would be 2 times negative 3. 2/3 times negative 3 is negative 2, x to the negative 4, because negative 3 minus 1 is negative 4. Right? So the 3 cancel. Whereas on part B, the derivative is negative 3 times 2 is negative 6, but you can reduce 6/27. 3 goes into 27 9 times. So it's negative 2/9, x to the negative 4. Okay, so you want to simplify that power before you raise it up. Sucks because in class I'd be doing the raise it up like I'm doing this with my hands, and we'll have live sessions next week, so everything won't be videos. This is terrible. What do you got on part C? Part C is 5x to the negative half. See, it's a square root, which makes it a half. It's also in the denominator, so you move it up, it's negative. So we'd done a square root problem and a cube root problem, but I hadn't put one in the denominator yet. It was negative half minus one more, 3 halves, right? Negative 50 cents minus $1 is negative $1.50 minus 3 halves. Cool, I'm done. I'll post some questions to go along with this video. I will also post these notes, this PDF. Okay, I will post the PDF.